Our next lesson is the second part of using the elimination method. So in the book, they call this solve by multiplying first. It's not anything really that different from what we did in section 6.3. The only difference is that most of the problems are going to have one or two extra steps. So just a little review, I want you to remember that if you want to eliminate a variable, you must have three things. You need to have your like variables and your equal signs lined up. If you look below on example number 1, you'll see that our x's are lined up, our y's are lined up, our equal signs are lined up, and so are our numbers, our constants. The other thing you need is the variable that you're going to eliminate to have the same coefficient. You'll notice that neither our x nor our y has that, so we're going to have to do something to one of those equations at least. The other thing you need is the opposite sign. Luckily, for the example below, both the x and the y's in the two equations have opposite signs. So now you need to decide which equation you're going to eliminate. And the way that you decide that is by looking at the two equations and seeing what you can multiply either the 2 or the 5 or the 3 or the 4 by in order to get something to cancel out. So if you're really, really, really good at this type of thing, or if you've done it in the past, you might notice that if I were to take the entire second equation and multiply it by 2, I would actually get something really nice. So what would happen would be that I would get 3x minus 4y equals negative 5, and negative 10x plus 4y equals 12. Now, suddenly this problem got a lot nicer. So now you might notice that I have some stuff that I can cancel out. If I add straight down, I will be able to cancel out my y's. So my x's, when I put them together, 3x minus 10x gives me negative 7x. Negative 4y plus 4y is going to cancel out. It gives me 0, so I'm just going to cross it out. Bring down the equal sign, and now I get 7. So then my answer for x is going to be x equals negative 1. The next thing that you need to do on this problem, same as what you were doing in the previous chapter. So now you're going to take your negative 1, substitute it back into any of the original equations. I actually don't care which original equation you do. I really like the second equation before I changed it. So I'm going to take that negative 5x plus 2y equals 6, and I'm going to substitute in that negative 1 for x. The reason I like this equation is because I knew that when I multiplied two negatives, I get a positive, so it's now a lot nicer. You're going to end up getting 2y equals 1. Be extremely careful with that. Y is not equal to 2. We have to divide both sides by 2. We end up getting y equals 1/2. The last thing I would recommend that you do is just double check. Make sure, you can even do it in your head if you want. Make sure that if you were to plug in x equals negative 1 and y equals 1/2 to the first equation, the one that you didn't use on that past step, make sure that you actually get a true statement. That way you can tell that you were definitely doing it right. And you'll find that you do get a true statement. So our answer is absolutely going to be negative 1, 1/2. So for example number 2, I'd like you to pause and try it on your own, please. For this example, we can still eliminate y's. You'll find that the easiest way to do that is by taking the top equation and multiplying it by 2. When you do that, you get 6x minus 6y equals 42. The bottom equation doesn't change. So then you have two equations. We now have y's. We have everything lined up. We have the same coefficient, the 6. We have the opposite signs, which is great. So now you can actually do this problem. Now you're going to add straight down. 6x plus 8x is 14x. Negative 6y plus 6y is 0, so I'm going to cancel it out. Bring down your equal sign. 42 minus 14 is 28. So our last step on this problem is, well, not on this problem, on this part of the problem, excuse me, is going to be to solve it. We get x equals 2. Next thing that we're going to do is substitute that 2 back into any of the equations you have above. I am going to use the top one that I had, just because that one has the smallest numbers. So I'm going to end up getting 3 times 2 minus 3y equals 21. I end up getting negative 3y equals 15. My answer for y is going to be negative 5. So your final answer is 2, negative 5. If you're taking a test or a quiz, especially a final exam, I highly recommend that you go back and double check and make sure that 2, negative 5 works in both equations. It's very important that you check that. So for number 3, we are going to have some extra steps in this one. If you feel like you can do this one, it's a combination of what we did in problems numbers 1 and 2, and also one thing that we did in the last section. If you feel like you can do it, go ahead and do it. Otherwise, I will go over it right now. So feel free to pause and try it on your own if you want. So this problem is slightly annoying because we have the bottom equation looks pretty good. It's in standard form, which means that we have an x, we have a y on the same side. It's equal to our constant, which is negative 10. Unfortunately, the top equation, there's a little bit of work to do. So we need to get it so that it's in the same format as the bottom equation. We do that by taking this equation and moving over that 9x. So we are going to move that over. 9x is positive, so we're going to subtract it. The other thing that's important is that if you were to write it as 5y minus 9x equals negative 8, that would be fine, except that you would have to do another step. Because if you look at the left, we have an x first and a y second. So I'm going to actually change the order. However, when I change the order, I need to make sure that the 9 stays negative and the 5 stays positive. You can't change your signs unless you're moving things over. So now I have my first equation rewritten nicely. And at this point, I can go and use both the first and the second equation. So my new rewritten first equation, and I'm also going to use the second equation from above. So my next step is similar to what I did in numbers 1 and 2. I need to get it so that I have the same variable with the y and opposite signs. So there's actually 2 things I have to do. I'm not going to bother with trying to eliminate the x, because if you look at that, 9 and 20 are not very pleasant numbers. With the 5, I know that if I multiply 5 times 2, I can get 10. So I'm going to multiply it by 2. However, as I was saying, I need the opposite sign. So actually, I'm not just going to multiply it by 2, but I'm going to multiply it by negative 2. The reason I'm going to do that is because then my 5s can eliminate. So I will end up getting 18x minus 10y equals 16. And then I have that second equation the same. Now I'm going to add straight down. So 18x minus 20x is negative 2x. Negative 10y plus 10y is 0, so I'm going to cancel it out. I bring down my equal sign, and I get 6. The last step on this part of the problem is to divide both sides by negative 2. which gives me an answer of x equals -3. So now I have a little bit more work to do. I have to find the y. So I'm going to use any of the equations I have listed above. I can use this first one I had that I changed. I can use one of these ones down here. I can use the bottom equation. However, I generally will go with the equations with the smallest numbers. And the first one, before I changed it, there's actually an added bonus, which is that the y is already on one side. And so since I'm solving for y, I'm going to use that equation. And I'm going to do that by substituting in -3 for x. So I end up getting 5y equals -27 minus 8, which gives me 5y equals -35. Thankfully, I'm going to get a nice number here. No fractions in this one. So I will end up getting y equals -7. Our last set of equations has actually a lot going on with it. There's a few different steps that you have to do. In addition to that, there's actually several choices that you can make. So you are going to multiply both equations by different numbers. Because right now, there is nothing that you can multiply anything by where you only do one equation multiplying by a number. In the last one, we can multiply 5 by 2, and we got 10, which eliminated, but in this one, it's not going to work, unfortunately. So we're going to multiply both equations, and we're going to do different numbers there. So make sure that you're doing both. And you actually have a choice here. You can eliminate either variable. I really do not care which variable you eliminate. It is your choice. So if you prefer the x, like if you like the 4 and the 5, that's fine. If you like the 2 and the 3, that's also fine. So the key thing that you need to do is you need to make sure that you get, first of all, they're already lined up, which is a good start, but now you need to look at the other two steps that we need. So the second thing that we need is we need the same coefficient for either the x or the y. And in addition, we need opposite signs. So what's going to happen is you have to multiply one of the two equations by a negative so that they can eliminate. Otherwise, you're going to get something that will not work out, and you'll just end up getting a more complicated equation in the end. So I'm going to eliminate y. I personally like that better because the numbers are a little smaller. So to eliminate y, you're going to have to look at what you have. You have a 3 and a 2. The easiest thing to look for is the least common multiple of 3 and 2, which is 6. So if we try to get 6, you would have to multiply the top equation by 2, the bottom equation by 3, and that would give you 6, and then you would be able to eliminate those. And the other thing you have to remember is that one of the equations must be negative. So one of the y's must be negative. So I'm going to multiply the top by +2 and the bottom by -3. If you multiply the top by -2 and the bottom by +3, that's fine. So I'm going to multiply the top equation by 2 and the bottom by -3. And when you do that, you will get 6y and -6y. So I'm going to quickly rewrite this, and then we're going to do that work. So now top equation is going to be by 2, bottom equation by -3. So make sure that you multiply everything by 2. Oftentimes when people are doing these more complicated equations, they end up forgetting to multiply the 2 by the 12. But you need to remember to do that. So make sure that you are multiplying each of those things by whatever number you multiplied by. So by the 2 or the 3 in this case. So now I have 2 equations. They are nicely lined up. My y's have the same number, but the opposite sign, which is really good. So now I can eliminate. I'm going to end up getting -7x equals 21, which gives me x equals -3. So now, once again, you can substitute that x back into any of the equations. You actually have 4 to choose from. You have the 2 equations before you changed them, and the 2 equations after you changed them. However, if you look at the original 2 equations, they have super small numbers, which is really nice. So I'm going to choose the original bottom equation, which is the 5x plus 2y equals 1. And I'm going to substitute in -3 for x. So I'm going to find out that my y will end up being 8. And you'll find that if you check back in your original 2 equations, x equals -3 and y equals 8 will work out.